architectural firm finds out what type of construction the client is interested in, whether it's building construction or civil construction. Building construction includes structures like houses, office buildings, stores, and factories.
Yeah, but what's civil construction?
Civil construction involves roadways like streets and highways, as well as more complex structures like bridges and sewage treatment facilities. Now, the firms that create these projects often consist of both architects and engineers.
Architects draw up plans, don't they?
That's right, while engineers concentrate on the details, like the size of the beams, the exact materials that will be used, and so on. Then, after the architects and engineers understand their clients' needs and desires, they have surveyors prepare a survey of the site. A survey shows everything on the site, including boundary lines, slopes in the land, and the location of existing greenery or structures. With this information, architects and engineers come up with a few thumbnail sketches.
What are thumbnail sketches?
They are very small drawings that allow architects to quickly rough out a few designs, like these. Eventually, the architects select their favorite sketch.
How do they know which one to pick?
Well, along with selecting a layout that looks attractive and meets the needs of the client, an architectural firm must make sure that the design meets a number of regulations. These include zoning laws, building codes, and local covenants. Do you know what any of these are?
Yeah, zoning laws tell you what type of building you can put up, right?
That's pretty close. Zoning laws regulate how many people or structures can be located in a given area of land, as well as the types of structures that can be built there. For example, commercial zones are intended specifically for structures like malls, restaurants, and grocery stores. Industrial zones, on the other hand, are for structures like factories and warehouses. Now, what sort of structures do you think are allowed in residential zones?
Oh, I know, houses.
Right. Houses, apartments, condominiums, and other residential buildings. Another category of regulations that can affect the construction of a building are building codes. These are guidelines for how a structure should be built, along with the quality of the materials being used. They're enforced by local building inspectors who may visit a site several times throughout its construction to make sure it's meeting all the necessary safety requirements. Building codes also apply to structures like dams, bridges, and highways. To give you an idea of what I mean, many highway overpasses, like this one, must have enough clearance for large vehicles to go under them, and also be strong enough for those same vehicles to go over them. Communities may also have local covenants.
Covenants?
Yes. These are often ordinances that regulate the size and style of structures that can be built in a community. Some covenants also specify the types of trees or shrubs that can be planted.
Boy, they're pretty picky.
Well, actually, covenants are meant to preserve the style of a neighborhood while protecting its market value.
Oh, okay.
Once an overall plan has been agreed upon by the firm, the architects and engineers design a series of detailed renderings.
Then do they start building?
No, there are other elements to the designing and engineering process, including getting client approval and selecting the general contractors who will assign people to do the construction work.
Boy, it takes a lot of people to build a house.
That's right, Karen. And there's another step that takes place before any construction is done.
What's that?
That's part of what is known as site preparation. All told, there are 3 elements to site preparation: removing unnecessary objects like rocks and existing structures, as well as leveling the plot and locating where the structure will go.
Wow, that's a lot of work.
It sure is. Preparing the site for construction takes the efforts of professionals like surveyors and operating engineers, as well as special tools, including earth movers.
Like bulldozers.
Exactly. And to determine the location of the structure, surveyors use tools like leveling rods and transits.
Well, everything I've heard so far sounds okay, but my teacher also wants me to talk about how buildings are put together.
Well, first you have to realize that there are 2 parts to any type of structure: the substructure and the superstructure.
What are those?
Basically, the substructure is the foundation system that not only supports the weight of the main structure, but distributes this weight over a large area. Now, the main structure, also known as the superstructure,
That's the rest of the building, right?
yes, the superstructure is what rests on top of the foundation. In all, there are 3 different kinds of substructures: slab foundations, spread foundations, and pile foundations.
How do architects know which type of foundation to put in?
They consider a number of elements: the type of structure, the type of soil, and the climate in which they're building. Slab foundations are best for small, lightweight structures where the soil is soft or has a lot of groundwater. One type of slab foundation is called a floating slab because it sits directly on top of the earth. Because of this, floating slabs aren't often used in certain areas of the country where the ground freezes in winter. You see, when soil freezes and thaws, it shifts and moves. So a slab foundation built on this type of ground would simply move along with it.
What about bigger buildings?
Well, depending on the soil, larger, heavier structures tend to be supported by either spread or pile foundations. If the soil is hard or near bedrock, a major structure may be built on a spread foundation, which places the weight of the structure on thick support walls. And depending on the depth of these walls, the space they create may serve as either a basement or a crawl space. However, in climates where the ground freezes in winter, they must be set below the frost line so that they won't shift when the ground shifts. But for structures like bridges, where the soil is wet or sandy, pile foundations are often used. On these, piles or posts are driven into the ground until they reach solid soil or bedrock. This keeps them from moving or shifting. Footings are then attached to the top of the piles.
I didn't realize all that work went into just putting in the foundation.
Well, it's important to construct a solid foundation so that the superstructure above it will be sturdy too. But along with there being different types of substructures, there are also a variety of superstructures. These include minor superstructures, major superstructures, and alternative superstructures, like geodesic domes.
Geo what?
Have you heard of the Epcot Center at Walt Disney World Resort?
Oh, yeah.
Well, it has a geodesic dome known as the Spaceship Earth. A geodesic dome uses a series of triangles to frame its outside shape. These triangles give the structure a lot of compression strength and transfer all the weight to the outside walls. That's why most geodesic domes don't have interior support beams or posts.
Hey, you're right. I never realized that.
But for factories, houses, and other traditional superstructures, supports are needed for framing and shaping. In minor structures like houses, studs, joists, and trusses are used to form the exterior walls, subfloors, interior partitions, and the roof. But in major superstructures, like this office building, Steel pillars and beams are used because they have the strength to support multi-story structures.
I think I've got that. But what about highways?
Highways and dams require massive amounts of either dirt, concrete, or stone. Take the Hoover Dam. It was made with large amounts of reinforced concrete. This allows it to contain the 30.5 million acre-feet of water in Lake Mead, the lake constructed for this project.
Man, what do they do with all that water?
It's used to irrigate thousands of square miles of farmland. And the dam generates enough energy to support most of the southwestern United States. Now, once the substructure and the superstructure have been completed, what do you think is the next procedure?
Well, I guess you put up the walls.
Actually, you're forgetting a few things that make a structure more comfortable.
Like what?
Utilities.
Oh, you mean plumbing and stuff?
Yes. Water and sewer systems are two examples of utilities. Electrical systems are another essential utility installed on most structures. After all, without electrical systems, you wouldn't be able to talk to me right now.
Hey, where'd you go?
Just kidding. Where was I? Oh, and without electricity, your house could get pretty hot in the summer and a little cool in the winter.
Well, I get why we need utilities. But why are they put in before the house is finished?
Because the walls and ceilings need to be open so that there is space to install air ducts for the heating and cooling, the wires for the electrical systems, and the pipes for the water and sewer systems. Then later, when the walls, ceilings, and floors are covered, the right fixtures, switches, and appliances can be installed.
Great. Now, when do you start painting and carpeting and...
Those are part of the enclosing and finishing phase of construction, which transforms an unfinished structure into a shelter. Shelters offer protection from rain and other bad weather, as well as from intruders. And in earlier times, they offered protection from predators. Other reasons for enclosing and finishing a structure include comfort and convenience. The structure's exterior is enclosed first, including the exterior roof, walls, windows, doors, and skylights. The interior is enclosed in much the same way. Interior walls are often covered with a material called drywall. The drywall may then be covered with paint, wood paneling, wallpaper, or one of many other materials. Floors are covered too, with materials like vinyl, carpeting, and wood.
So, is the project done yet?
No, the finishing process also includes adding trim to the interior and exterior of the house, as well as installing accessories. Some bathroom and kitchen accessories include cabinets, faucets, shelving, and light fixtures. Accessories must also be added to civil structures. Highways, for example, need accessories like pavement striping, guardrails, reflectors, and signs. Also, finishing is usually done to the plot or land surrounding the structure, which may include constructing pathways.
Like a sidewalk?
Yes, sidewalks and driveways. In addition, commercial and industrial sites may also have parking lots. Landscaping is another element of finishing a site. This can include planting trees, grass, and other greenery. The last step in finishing a structure involves giving final inspections, paying all materials suppliers, and having subcontractors and suppliers sign work releases. With that completed, the general contractor collects the owner's final payments and then transfers the responsibility of the project to the owner.
You know, you've been a lot of help. I'll have to talk to you when I get to my other industrial technology projects.
What other projects?
See you later, computer.
Oh, brother.